Welcome to our lesson on VSEPR theory. VSEPR stands for Valence Shell Electron Pair Repulsion Theory. This theory helps us predict the three-dimensional shapes of molecules based on the arrangement of electron pairs around the central atom. The basic principle of VSEPR theory is simple. Electron pairs around a central atom repel each other and try to get as far apart as possible. This minimizes the repulsive forces between them. The arrangement of these electron pairs determines the molecular geometry. There are two types of electron pairs we need to consider: bonding pairs, which form bonds between atoms, and lone pairs, which are not involved in bonding. Both types influence the molecular shape. The total number of electron pairs around the central atom is called the steric number. The VSEPR notation X sub Ne sub m is used to classify molecular geometries. Here, A represents the central atom, X represents the number of bonding atoms, and E represents the number of lone pairs. For example, X3 means the central atom, A has 3 bonded atoms X, and no lone pairs. Now, let's look at some common molecular geometries based on steric number. X2, linear geometry. Example, carbon dioxide, CO2. X3, trigonal planar. Example, boron trifluoride, BF3. X4, tetrahedral. Example, methane, CH4. Let's continue with more geometries that include lone pairs. X2E2, bent geometry. Example, water, H2O. X3E1, trigonal pyramidal. Example, ammonia, NH3. X5, trigonal bipyramidal. Example, phosphorus pentachloride, PCl5. Let's solve a problem. Determine the shape of a water molecule, H2O. First, let's draw the Lewis structure. Oxygen has 6 valence electrons. 2 electrons are used to form bonds with hydrogen atoms, leaving 4 electrons, which form 2 lone pairs. So, the VSEPR notation for water is X2E2, where oxygen is the central atom, A. There are 2 bonded atoms, X, hydrogen, and 2 lone pairs, E. Therefore, water has a bent molecular shape with an angle of approximately 104.5 degrees, less than the ideal tetrahedral angle of 109.5 degrees due to the greater repulsion from the lone pairs. Let's summarize what we've learned about VSEPR theory. First, the arrangement of electron pairs around a central atom is determined by electron pair repulsion. Second, both bonding pairs and lone pairs influence molecular geometry, with lone pairs often causing greater repulsion. Finally, we can use VSEPR notation to classify molecules and predict their shapes. This theory is crucial for understanding molecular properties like polarity, reactivity, and even biological function.